Hello friends. First, we will see the definition of coordination chemistry. Coordination chemistry is the branch of chemistry which deals with the study of coordination compounds or complex compounds. It means it is the only branch of chemistry which deals with or which studies the coordination compounds. What are coordination compounds? Coordination compounds are nothing but the central metal atom or ion that is surrounded by the atoms, molecules or anions called as the ligands that are bonded by the coordinate bonds. Here we can see in the image cobalt, that is the central metal atom surrounded by the two chlorine atoms, anions, and three ammonia molecules. In this way, this is a coordination compound. In previous slide, we have seen the word ligand. Now, what is ligand? Ligand is a Latin word. It means bind. Now, the definition of ligand is a molecule or ion that is directly bonded to metal ion in a coordination pair. For example, in this case, we have seen that there are 6 cyanide groups which donates their lone pair of electrons to the central metal atom, that is the iron, and forms the complex. It means that the 6 cyanide groups are the ligands. Now, central metal atom and the 6 cyanide groups written, they are called as a coordination pairs. They are written in a square brackets, and the number of ligands attached to the central metal atom, that is called as a coordination number. The formation of a coordinate complex is a Lewis acid-base reaction. Simply, we can see that in the image that cobalt ion is acting as a acceptor of the electrons, and acceptor of the electrons is called as a Lewis acids, while that of 6 ammonia molecules are there, and that ammonia molecules donates their lone pair of electrons to the cobalt ion, and in this way they are behaving as a Lewis base, and the number of ligand bonded to the central metal atom is termed as the coordination number. It means that there are 6 ammonia molecules, they donate their lone pair of electrons to the cobalt ion, therefore 6 ammonia molecules are the ligands, and the number of ligands is a 6, therefore that is the coordination number of the complex. The basic idea is that the ligand is providing electron density to the metal atom or ion. Now, the bond from ligand to metal is a covalent bond because there is a sharing of electrons, but both electrons comes from the ligand. Therefore, this is a coordinate covalent bond. Now, in example, we can see that cobalt, that is a acting as a Lewis acids, accepting electrons pairs actually from the ammonia. Actually, ammonia is a neutral molecule, but in ammonia nitrogen contains the lone pair of electrons, and it donates its own lone pair of electron to the central metal, that is the cobalt ion. Therefore, the bond between the ammonia and cobalt is a coordinate covalent bond. In the previous slide, we have seen the definition of ligands. Now, we have to see types of ligands. Ligands are classified on the basis of number of donor atoms present in the ligands. They are classified into firstly 2 types, that is the monodentate and polydentate. Dentate means teeth by which it is attached to the central metal atom or ion. Polydentate ligands are again classified into bidentate ligand, tridentate ligand, tetradentate ligand and hexadentate ligand. Monodentate ligand contains only one donor atom, while that of bidentate ligand contains 2 donor atoms. Tridentate ligand contains 3 donor atoms. Tetradentate ligand contains 4 donor atoms, and hexadentate ligand contains 6 donor atoms in a one molecule. Another type is there that is ambidentate ligand. Ambidentate ligand contains 2 donor atoms, but out of that only one donates its lone pair of electron to the central metal atom. Therefore, it is called as a ambidentate ligands. Polydentate ligands are also called as chelating agents. Chelating agent means the ring forming agents, because when polydentate ligands attach to the central metal atom at two sides or more sides, then it forms the ring. Therefore, they are called as chelating agents. Monodentate ligands. Examples of monodentate ligands are water, cyanide, ammonia, nitro, thiocyanate, etc. All these examples contains only one donor atom that contains the lone pair of electron and donates to the central metal atom. For example, in water, there is oxygen contains the lone pair of electrons. In cyanide, there nitrogen contains lone pair of electrons. In ammonia molecule, again nitrogen contains the lone pair of electrons, and etc. The example of complexes are hexaamino cobalt ion, and another example is there given is hexathiocyanopyrate ion. Examples of bidentate ligands are oxalate ion, C2O4 dinegative, ethylene diamine in NH2CS2CS2 NH2, orthophenanthroline, etc. The structure of bidentate ligands are in this way. Oxalate ion contains total 4 oxygen atoms. Out of that, 2 oxygen atom donates the lone pair of electron. Ethylene diamine contains 2 nitrogen atom which contains the lone pair of electron, and that donates the electron to the central metal atom and forms coordinate covalent bond. Examples of tridentate ligands is diethylene triamine, which contains 3 nitrogen atom which acts as a donor atom to the central metal atom or ion, and in this way there is a formation of 2 rings. We can see in the image, when nitrogen donates their lone pair of electron to the central metal atom, they forms the ring, and therefore they are called as chelating agents. Example of tetradentate ligand is triethylene tetramine. As tetramine, it contains 4 nitrogen atoms, and these 4 nitrogen atoms donates their lone pair of electron to the central metal atom. We can see in the image that 4 nitrogen atoms are there, and they donate the lone pair of electrons to the central metal atom and forms the 4 coordinate bond, but at the same time they forms 3 rings also, and therefore they are called as a chelating agents or ring forming agents. And now we will see the last example of polydentate ligand, that is hexadentate ligand. It contains 6 donor atoms. The example of hexadentate ligand is ethylene diamine tetraacetate. It is also called as EDTA, and this is a formula of EDTA. Now we will see the structure of EDTA is likewise. Ethylene diamine, we can see CS2 group at the center, and 2 nitrogen atoms are attached to the tips of that CS2 group, and to that nitrogen atoms there are 4 acetate ions are attached. Out of that, now 2 nitrogen atoms donates the lone pair of electron, and the 4 oxygen atoms which are at the tip of the EDTA donates the electron. In such way, there are 6 donor atoms are present, and this is how it is attached to the central metal atom or ion. Look in the picture. Nitrogen atom donates their lone pair of electrons to the cobalt and forms 2 coordinate covalent bonds. At the same time, 4 oxygen atoms which are present at the tips, that 4 oxygen atoms donates their lone pair of electrons to the cobalt and forms the coordinate covalent bond. In this way, one ligand EDTA, ethylene diamine tetraacetate, that contains 6 donor atoms, and all that 6 donor atoms donates their electron to the central metal atom and forms the 6 bonds, coordinate covalent bonds. And the last type of ligand is ambidentate ligands. The definition of ambidentate ligand is if a ligand has two or more donor atoms, however, while a complex is formed, only one donor atom is attached to the metal, then it is called as ambidentate ligand. It means that ligand contains two or more donor atoms, but out of that only one atom donates the electron to the central metal atom. Example given in NO2. NO2 group, there are two donor atoms, but nitrogen and oxygen. If oxygen forms the bond with metal ion, it becomes nitrito, and if nitrogen forms the bond with metal, it becomes nitro. In this case, out of oxygen and nitrogen, only one atom donates their electron to the metal. Similarly, in SCN group, there are two donor atoms, nitrogen and sulfur, but out of that only one donates their electron to the metal atom. If sulfur donates the electron to the central metal atom, it becomes thiocyanato, and if nitrogen donates their lone pair of electrons to the metal, then it becomes isothiocyanato. And here we have finished the types of ligands. Now in next lecture we will see the remaining part. Thank you for watching.